started.
Cool. So yeah, my talk, at least the title is something that I just invented. So it's called Serverless. That's the trademark there. That's because of it. And it's about a new web, a web that I discovered. And I think that my mission here is actually to make you know it and hopefully get a better interest from all of you in this subject. So, as Marco said, I'm André Cruz. I'm CTO at Moxie. You can find me on Twitter, GitHub, and that's also the link of our awesome website. You can check it out, and actually, I will actually use it to show some of the demos that I've here. So, serverless, in the sense of the short term, and I'm quoting here Wikipedia. Is a cloud-based model in which the cloud provider acts as a server, dynamically managing the allocation of machine resources. So, and moreover, what it means is that for us as developers, it really hides the infrastructure, it hides the servers from the development cycle. You just need to worry about the dependencies, like a database, and the cloud provider will provide that for you, and it will scale whenever necessary, both up and down whenever the service needs. And I'm quoting also Burke Holland. Of course, nothing is actually serverless in the true sense of the word. There are always servers, right? So what this means is that most of the apps that me and you use nowadays are behind servers. And most of the probably social networks that you use, for instance, they use a lot of servers to to provide all the capacity necessary for all its consumers. So what this really means is that the web of today is mostly centralized. And to better illustrate what I mean by centralized, I'm making here an analogy where I simply remove the internet out of the equation. So let's go into the real world. Let's say that we have here Alice that wants to send a message, or better, she wants to send a post to its wall on Facebook. She would literally have to walk to the Facebook building to write the post on her wall. And if Bob wants to check Alice's wall, he also needs to walk into the Facebook building and retrieve to see the post. So this is really what's going on in the centralized world. I raised some questions about this way of doing things. And the first question here is, what if the Facebook building is closed, for instance? An analogy here is, imagine that Facebook has an outage and is down for some time. You can't really go there because the building is closed, right? And also, we don't never know, but in 10 years or 20 years, Facebook can actually close as a company. And if it closes, you can no longer use Facebook as a service. The next question here is, what if someone denies your entrance to the Facebook building? Like a guard saying, hey, you can't enter here. We don't actually experience that now, like in Portugal and mainly in Europe. But let's say that you, as a tourist, go to China to visit the Great Walls of China, and you take some photos there, and you want to post on Facebook to share with your friends. You can't really do it there. They will block your access to Facebook and also many other services. But what if there's no transportation to take you to the Facebook building? Like let's say that you have to walk a lot of distance, and you better use a car or something, but you don't have any car nor public transportation to take you there. An analogy here is that you might be offline. You might not have an internet connection at all. The next question is, what if there's transportation, but there's traffic jam? For instance, like in the Facebook building, that might be a huge line of people wanting to enter the Facebook building. And the Facebook building is not scaled to handle that much people. It might happen. It's actually happened many times before. And this is the scary one. What if the Facebook building is robbed by someone? It really means that the data that's stored there gets compromised. We receive like those emails even now and then saying, hey, your data has been compromised, and you're screwed basically, because your data, your name, your personal information is everywhere. Even encrypted passwords get leaked, and that's not a good thing. And if you think about this, all of this might happen because you don't own the data nor the service. It's Facebook, in this case, that holds the data and the service, right? And this, again, Facebook is just an example. The whole web is just this, basically. So this is pretty similar to the diagram that Alex shown, but essentially what you have today is that blue dot is like Facebook, for instance, and there's a lot of devices connected to Facebook in order to consume it. And it will grow over time because we are in a phase where there are a lot of devices coming up. Our cars, our TVs, even our fridges later on, our Bimbis later on will be connected to the internet and will be consuming the internet. It will grow over time. And what we want to become is really more like the second and the third diagram, hopefully more like the third diagram, where every node is as equal as the other node, right? And if you think about it, this is really a very different paradigm for the web. It makes really, like the way you develop apps is really different. It's very different, really. And you have to account for that. But it's a web, it's really a web, and hence the title of my talk. It's a web where there are no servers nor clients, because everyone is both. Everyone is both a client and a server. And also, it's a web where the data is open, because it lives on our devices. It's ours. It's not it doesn't belong to the owners of the service. It's in our devices, instead of living in silos, right? And also, it's a web where there's opportunity to make different applications for the same data. Like imagine if the Facebook data were in our devices, we could have different applications acting as like Facebook, but with better UI and UX, or even new features, for instance. And the name of this type of applications is commonly named as decentralized apps, or just dApps for short. So let's ask Google, how can we build an app today? And if we ask Google, we have like this set of results, mostly Ethereum-alike, if you see there. And Ethereum is a blockchain. And yes, that last result, if you open, it's also Ethereum. So what is a blockchain? Well, I'm not going to cite this whole thing because it's like a complex definition for me to transmit. Everyone just knows that a blockchain is a simple linked list with a few extra steps. And yes, it's mostly correct because it's like an order of events that must occur, and the next event must pass through some validation to ensure that it's the same across all the network. That's all that you need to know at this point. So, but blockchains are very powerful, especially the ones that allow to do cool stuff with smart contracts, for instance. And even those are necessary whenever you need consensus. But ultimately, they can be costly, because whenever you write data, like make a transaction, you have to pay for that. And also, it might be slow, because whenever you do the transaction and you pay for it, it might take a few seconds to get settled on. Like it can take 10 seconds, or even, in the worst case, some minutes. And of course, it requires connectivity in terms of being connected to the whole network of the blockchain in order for you to make a transaction. So the question is, based on all the disadvantages that I said before, is that it for dApps, or is something else? And yes, there is something else. There's a library that I've been using and also contributing to, which is called PeerStar App, which essentially uses two awesome technologies. which is IPFS, and that Alex already presented that for me, so I don't need to explain it again. And also uses CRDTs, and if you were in the previous OPO.js meeting, I think Pedro Teixeira actually explained those, but essentially it stands, like CRDT stands for conflict-free replicated data types. And in short, what it does is that if you have two devices with a set of data and you want to merge the data, the CRDTs kick in and allow them to be merged and to converge to the same data. So the devices, after they are converged, they all see the same data exactly by the same order and so on. So what does it allow us to do is it allows us to do real-time collaborations. It allows us to be offline first because the data lives on our devices and the code to operate also. So we can just run the application in our own devices and operate offline. It provides an effortless synchronization of data thanks to CRDTs. CRDTs, as you will see, we have some built-in types, just like arrays, objects, counters, and many other types. But you can also make your custom CRDTs whenever necessary for some complex scenarios. And of course, thanks to IPFS, is a peer-to-peer network and storage. So we have this huge goal, which is for Peer-Star app to become the Firebase of apps. So I think like Firebase is a very neat technology, to make, it really makes easy for developers to make apps and deploy them. And we aim to be as easy as Firebase, but for the dApps world. Of course, with Firebase, when you want to go to production, you're going to pay. With Peer-Star app, it's different. We don't really need to pay. Anyway, you have the repository. It's hosted on IPFS Shipyard / Peer-Star app on GitHub. So this is demo time. I'm going to actually do an exercise here. And I will ask you to open a link on your mobile devices so that we can experience the collaboration in real time here while I develop the application. So what I'm going to do is do two things. I'm going to tweet this link so that it's better for you to open on your devices. So my account is Satazor. So I'm going to just put it there. I put a hashtag OPO.js, OK. Link for demo, OPO.js, hashtag. Like this? Yeah, OK. Anyway, if you want to access it, I'm going to just zoom in this console. OK, it was too much. Let me put it more up. OK, I think I can keep that screen for a little bit, so in case you want to access it directly. Anyway, the exercise here is to take a to-do app, and I think many of you already know this kind of application. It's a simple to-do app where you can just add to-dos, like present on OPO.js, and eat some pizzas, because we want to eat some pizzas. Cool. And you can mark, of course, as completed. You can remove a to-do, and so on. So, of course, this app, it's only working locally on your device right now, because it's local. But the exercise here is to go into a code editor and transform it using that library, Peer-Star app, into a decentralized version where we can all collaborate on this to-do. So just bear in mind that please don't write bad things in there, because this will be, it's being recorded, so please don't put, OK, so can you see the code there, or can you see it well? More or less? Better? OK, cool. So the first thing that I want to do is to import the library. So in this case, Peer-Star app. We're going to create the app. And I'm going to be really fast because I don't have much time. You can ask me questions later. So in this case, I need to give the app a name, just similar to Firebase. But in this case, I have to follow this name because I have already prepared it. In this case, I'm going to call it to-do app. And before continuing, let me just show the structure of the app. This is a simple, React app that has this file called to-do store, which is really the file responsible for loading the to-dos, adding a to-do, removing a to-do, updating a to-do, and so on. If you can see, you have load, add, remove, update title, and update completed. So I will go through all these functions in order to make it decentralized. So as I said, I need to create the app, and I'm going to start by the load function. I need to make it async, because I'm going to use a wait. So first thing that I need to do is to start the app and wait for it. Also, I need to create a collaboration. So I'm going to just put a variable here, collaboration. And I'm going to create it. In this case, I will do collaboration equal app collaborate. And I also need to give it a name. If we all will have if the name was the same in our devices, we'll be collaborating in this specific collaboration. But we can have as many collaborations as we want. So in this case, I also have to follow this name, which is the list of OPO.js to-dos, right? And the next argument here is the CRDT type. And this is the most important part because the model of to-dos is an array of objects where each object has an ID, has a title, has a checked flag, Boolean, basically, and so on. So it's an array. So I'm going to use RGA, which is a CRDT that it acts as an array. It's basically an array underneath. And I also need to wait for it. And if you see, I'm storing the to-dos in a to-dos variable here. I'm going to do the same here, but I'm going to read from the CRDT current value, which we can assess by shared. Shared, by accessing shared, you're accessing the CRDT instance. And it has this method called value, which returns an array, the current array of the state stored inside the CRDT. What we really need to do next is to listen to an event, because this is an event emitter, the collaboration. We want to listen to an event called state changed, which is triggered or emitted whenever the state changes, or the CRDT state changes. It can be, it can come from me, because I can be interacting with the app, or it can come from another device, just like you in this stage. And what I'm going to do, in this case, I'm going to update the to-dos variable, of course. In this case, I'm going to just copy that line. Okay, cool. And of course, instead of, the old code was reading the to-dos from the local storage and was doing some other stuff. I don't really need that. I'm just going to return the to-dos that I already have. So I think the load function is already coded, and hopefully it will work. Let's go on to the next function, which is the head function, which essentially just pushes to-do to the end of the list, as you see here. I'm not mutating the array. I'm creating a new array where it has the previous items and the new item. So instead of doing that manually, I'm going to call collaboration shared push, and I'm going to push the new to-do because I've chosen an array like CRDT that has a similar method to arrays, which is push, of course. And notice, have you noticed here that I have playability state change, which is a function that iterates over all the subscribers to inform of the change of the store, which basically the React will listen in order to re-render the list of to-dos. But I don't need this here. I can actually move that line over here, right? So whenever the state change of my CRDT, I'm going to inform the subscribers. In this case, I'm going to inform the React app. So adding on to the remove function, I will just go faster now. I'm going to just use collaboration shared, And in this case, I'm going to remove, so it's remove at index. Okay, and for the update part is very similar. We just need to call update at index and the new to do. Sorry, I removed the new to do, the updated to do, yeah, that's there. Update that, update at index, updated to do. I'm gonna just copy this because the update completed is pretty much similar. So I think we are ready to test it because these two functions are, just reuse the functions that I've previously changed. So I think it's enough. One thing to notice is that I have a lot of code here to store the items on a local store, but I don't need this anymore because the peer startup already stores this data for me. In this case, it's not using the local store, but it's using the IndexedDB, but it's similar, so I'm gonna just remove that. We don't need like these imports. We don't need these anymore. So we can just get rid of that. And also, we want to represent the number of peers within the collaboration. Hopefully, when I test this application, your devices will be seen by me, and you will be seen as well. I will be connected to each of you in this room. So I'm going to just uncomment this function and listen to an event called collaboration on membership changed, which is emitted whenever the number of peers or the set of peers change. So changed. I'm gonna grab the peers and I'm gonna call this thing. Okay, I think we are done. So let's test it out. So I'm gonna refresh the browser just to be sure that I have the latest changes, and I'm gonna type what I typed before. So give a talk at OPO.js, and eat some pizzas with some emoji as well. Cool. So it seems to be working, but now I'm gonna open a lot of browsers, like Canary, for instance. I'm gonna open Safari as well. I'm gonna open Firefox as well. Oh, there's an update, sorry. Should be quite fast, I think, if my mobile connection helps out. And also, I'm gonna actually open the same page, but on my mobile device. Bear in mind that I'm not using the tunnel because I'm really afraid of the network being slow. So yeah, I'm gonna just use the localhost. So as you can see, Safari, Firefox, and Canary all sync together. Give me a moment just to open the same thing on my mobile device. Should be this one. Yeah, seems to be working. So we should see 5 peers, yes. So my mobile device just joined the collaboration. I'm gonna actually type something on my mobile device, like talk to awesome people. And it should appear. Yes, it appeared in every peer, every browser that we just opened. Cool. So before we actually leave the demo, I'm going to disconnect. So in order to simulate an offline scenario, so I'm gonna like turn off my Wi-Fi, and I'm gonna write each name of the browser in the to-do list, and see if after we get back online, we sync together. So in this case, this is Chrome, right? This is Firefox. This is Safari, and this is Google or Chrome Canary. And give me some time to write also in my mobile device, so it will be iOS Safari. Cool. So if we connect, hopefully this will work out. So every peer will be back online and connect to each other, and they will sync everything together. So as you can see, you're already seeing the merging kicking in. So yeah, it seems to be working on Chrome, on Canary, on Safari as well, and in Firefox. So it seems to be working fine, just fine. So yes, heading back to the presentation. By the way, this workshop that I've presented here is available on this GitHub link. So you can just follow the walkthrough there to make this app, this to-do app, decentralized. What I'm going to do now is, I want to make an announcement, and this was the announcement that I've tweeted yesterday. So I've been working on this application called Discussify, which essentially allow you to have discussions on the internet, similar to things like Discuss or even like the Facebook comments that you can embed on any web page. It's very similar to that concept, but it's fully decentralized. So in order to show it working, I'm actually get out of the demo, and so that you can see fully decentralized okay, it did open. So I'm going to use like Moxie's website just to show the extension working. Okay, I think yeah, okay. Cool, so the extension looks like this, like it's a sidebar where it gets expanded, and you can see the discussion here. I'm like asking Marco to just join the conversation. Hopefully in some seconds it will appear up there. If it doesn't, well, it's because of the internet, again. So essentially what you have here is basically a discussion. I can make something like, I'm proud, and put some emoji like this. And bear in mind that I'm still like offline, or my internet is flaky at the moment, and I can still use the application, right? It acts perfectly offline. It's offline first. I can make some editions as well. Oh, I already see Marco, at least one peer there. So yeah. Okay, yeah, we just see a new comment from Marco. At least this is working. So yeah, this is a fully decentralized and peer-to-peer dApp based on the library that I've made before. Our plans is at the moment, this is very experimental. It means that the data might be lost because we are not worried by breaking changes in the data format. So it might like it's experimental, so it might not, you might lose your conversations, but at least it's a way for everyone in this room to experience it and to give us feedback on how you feel about this technology. So I think Marco or someone already replied there. It might take some time because the internet is not that good. Yeah, okay. So Mark Oliver just said OPO.js technical problems are awesome. See that Vicia-JS. Cool. So, okay, heading back to the presentation. To finalize, I really think that the web of the future will be decentralized by default, right? And decentralization will only happen whenever necessary. Of course, this will take many years to achieve this, but I really think that the decentralization of the web will happen. It's like saying that I will die. I know that I will die. I will not be immortal. I don't know when, but it's inevitable. I really think that the decentralization of the web is going to happen. It's inevitable. It's just a matter of time. So I make a question to everyone in this room. Are you ready to be part of this new web? And that's it. Thank you very much.